So if you want to do probability, you have to be able to count things. And so that's what we're going to discuss in this screencast: counting, permutations, and combinations. And we're going to start with the fundamental counting principle. So it says that the number of ways in which successive things can occur is found by multiplying the number of ways each thing can occur. Alright, so if that's confusing, let's do an example and maybe it'll be clearer. So we've got Perfect Pizza, and they offer its customers 3 types of crust: thin, regular, or pan; 2 types of cheese, mozzarella or parmesan; and 5 types of toppings: pepperoni, sausage, mushroom, green pepper, or extra cheese. Assuming you can order 1 of each crust, cheese, and topping, how many different pizzas can you choose from? Okay, so for example, if I pick thin crust, then from that I can get 2 types of cheese, mozzarella or parmesan, and from each of these I can get 5 types of toppings, right? So I'm not going to write them all out, but you get the idea. Okay, so you can do a tree, but the easiest thing is just to do the fundamental counting principles, which says multiply the number of ways each thing can occur. So I can have 3 types of crust times 2 types of cheese times 5 types of toppings, and I end up with 30 different ways I can create a pizza. That's called the fundamental counting principle. Alright, now let's talk about permutations. A permutation is an ordered arrangement of distinct objects without repetition. And ordered is a key word, okay? So let's do a real simple example. How many permutations are possible for the letters A, B, and C? Well, of course, we can do ABC. We can do BAC. We can do BCA. We can do CBA. We can do CAB. And finally, we can do ACB. Each one of these is a different permutation because the order of the letters is different in each one. So we have a number of 6 different permutations for 3 different letters. Okay, so it turns out that there is a formula for the number of permutations of n objects, and that is the first slot is taken up. You have n choices. Then once you've chosen 1, you have n minus 1 for the next slot. Once you've chosen 2, you have n minus 2 for the next slot, and this works out to what we call n factorial. So the number of permutations of n objects taken r at a time we write as n permutation r, which is n factorial over n minus r factorial. So this is if you're doing all n objects, and this is if you're doing r objects out of a group of n. And on the calculator we can do permutations. If I go to alpha F2, you'll notice it's number 7. And so if I wanted to do number of permutations of 5 objects out of a group of, or number of permutations of, let's say, 3 objects out of a group of 5. So I'll hit 5 right there and 3 right there. So I have 60 different permutations of 3 objects out of a group of 5. Alright, so here's an example from sports. There are 25 members of the cross-country team, but only 7 can compete in a meet. How many different lineups of runners 1 through 7 can the coach put together? So the order is important because we're doing the first runner through the 7th runner. So we're going to have permutations of 7 out of 25. That's 25 factorial over 25 minus 7 factorial, which is 25 over 18 factorial. Or we can use our calculator, and I can go to alpha F2 and pick number 7, and I'm going to put in 25 there, and I'm going to put in 7 there, and we get a whole lot of different ways we can do a lineup. Let's see. That is 2, 4, 2, 2, 7, 2, 8, 0, 0, 0. So that's, wow, 2,422,728,000. That's a lot of different lineups just from choosing 7 out of 25. All right, now a combination is a little different. A combination is an arrangement without specific order, so the order does not matter, of distinct objects without repetition. So how many different three-letter combinations are there of the letters A, B, and C? Well, here's the deal. ABC, BAC, CAB, all of these are the same combination because they're the same three letters. So the answer is there's one combination of the letters A, B, and C because we're using all three letters. So let's change the problem a little bit. How many two-letter combinations are there of the letters A, B, and C? Okay, so that's different. Okay, A, B is one combination, and that includes BA because order doesn't matter. AC is another combination, which includes CA. And finally, BC is another combination, which would also include CB. So there are three two-letter combinations of letters A, B, and C. And we would write that as 3, choose 2, which you'll sometimes see written like this. And here's the formula for that. The number of combinations of n objects taken r at a time is n factorial over n minus r factorial times r factorial. And once again, we have that on our calculator. If I hit alpha F2, you'll notice that it's number 8 and choose R. Okay, so here's an example. In a lottery, there are 59 numbers for players to pick from for a 6-number ticket. And in this lottery, the order of the numbers does not matter for you to win. So how many possible combinations are there? So we're doing 59, choose 6. Okay, so that's 59 factorial over 59 minus 6 factorial times 6 factorial. I'm going to use my calculator here. So I'm going to go alpha F2, choose number 8, put 59 in there, and 6 right there, and we get 450,57474. Okay, so how many different combinations are there? There are 45,057,474 different combinations of choosing 6 numbers out of a pool of 59 numbers.